Now that we have set all the data in our Bayesian network, in our CPTs, okay, now we can play around with the Bayesian network and try to do evaluate some scenarios, okay? So, for example, what we can do here, again, using the show evidence method, is like consider this scenario. What if we had all the children having reaction, for example? This is not mentioned in the textbook, but since we have the data and we have the vision network constructed, we can play around with those things. What if we had all the children having reaction? What would be the death rate? Okay, so we set the evidence here, uh, reaction equals to true. So that would be the probability of, we want to look at death, right? So death, given that reaction is equal to true or 1. Oops. Okay, so this is basically what we are doing. Okay, and well, I'm just using D here because we are going to look at the true and false, right? So we don't need to specify any of that. So I've just set the evidence over here, the show inference method. So shift enter, let's run it. It's calculating. Usually it's faster than this. Okay. So when we set an evidence, we see that those nodes where the evidence was set in orange. Okay, so it changed the color just to indicate what was set before. And it shows also when we set one state to true, so that it shows 100% for that state. Okay, so we see here the probability of death, it's 1%, right? Death 1 means death through 1%, 99% it's false. Okay, so if all those children they developed some kind of reaction. And we can even set other evidences as well. And so we can set, for example, reaction true, and let's try to do something crazy. A vaccine false, okay? So let's see what's gonna happen. So I should close the curly brackets over here, okay? So shift enter. So we set the two variables over here, the vaccine and also the reaction. So we see the probabilities updated, okay? I should say that we have a very small amount of data, okay? And Bayesian networks, they can be easily misinterpreted. Okay, so we can draw some conclusions that are not true if we do something that doesn't make sense at all. So we should be very careful when we are considering scenarios with Bayesian networks, okay? So this is how you set the evidences. So let's take a look at, let me just erase this thing. So let's take a look at the image of the graph again. And the question there is vaccination beneficial or harmful? Okay, so let's play a little bit about that. So if we consider the vaccine equals to 0, so nobody took the vaccine, right? So we can have some numbers out of that, okay? So we see everybody didn't take the vaccine. So we have this death rate. Okay, consider the data, consider all the probabilities that were updated in background by PyAgrum. Okay, so let's do some math over here. Consider the situation that was stated before. Right here, 1 million children. This amount was vaccinated. These have a reaction. So let's consider 1 million children, okay? 1 million, 3 more zeros, right? So 1 million children, okay? How many of those they got smallpox? So this is the verbal smallpox over here. We have 2%. Okay, so I'm just gonna copy and paste a print statement that I have over here. So have gotten smallpox 2 of 100%. Okay, so 2% over here, and I just multiply the number just to get the result. Okay, just to have a numerical value for that. So that means 20 children got smallpox with no vaccination. Okay, so I'm taking the data from the graph after doing the inference where nobody took the vaccine, 100%. They didn't take the vaccine. Okay. How many have died by not taking the vaccine? So these correspond, according to our graph, this is 0.4%, right? 0.4%. So let's just run. And then we have 4,000 children would have died without vaccination. Okay. Now, considering the explanation we have in the book, like here, I'm just taking the data from here. Those died from vaccination. Okay, this is in the book. This is not part of our Bayesian network yet. So 99% died from vaccination and 40 died from vaccine, from the disease. Okay, so we're just gonna put another print statement over here just to show those numbers. Okay, so 99 plus 40, this is exactly the number we have in the book. Okay, again, I'm basically reproducing what's there. So that means in total 139 children will have died by taking the vaccine and because of the disease. Okay, now let's take a look. Let's compare how many will have died from the vaccine without the vaccine compared to with the vaccine. Okay, so I have this next print statement over here. So the first part here is those 4%, this exact number over here. People died with no vaccine. Okay, so this is the number we got earlier. And then here we are considering the situation where the people, they took the vaccine, that percentage that was described before, they took the vaccine, right? They took the vaccine, and even though they died from the disease. So we have these 139 children that died by taking the vaccine. Okay, so what I'm doing in this last pretty statement, it's basically comparing what is the impact of do not taking the vaccine and take the vaccine. What is the difference of deaths? Because this is what we are interested in knowing right now, right? So let's run it again. So the result here would be 3,861. So that means the amount of children without, by not taking the vaccine, that was 4,000, not taking the vaccine, and the amount of children that will unfortunately die because they took the vaccine and also they had smallpox, because there is some kind of probability, very small for that. Okay, this is 139. So that means our last print here shows that without taking the vaccine, a lot of more people will die than taking the vaccine. Okay, so again, the difference here is almost 4,000. And we know 4,000 is the amount of children that will die without taking the vaccine. If they do take, we have the number of 139 that will die, right? So if children take the vaccine, we can save 3,861 children. Although some of them will die, of course, but at the very end, according to the data that was provided in the book, and this is the conclusion of the book as well, this is not my conclusion, 3,861 children will be saved because of that, just by taking the vaccine, okay? So again, this was just an example how to implement and use Bayesian networks doing inference. What I reproduced here is what is described in the book. If you check the book, those numbers will match as well, okay? Those are not my conclusions. I'm not say anything about that because it's, I understand this is a very polemic discussion. But based on the data, based on our analysis, most people, most children, a lot of children will be saved by taking the vaccine. Okay? And this is the conclusion of the book. This is what is described over there. I hope this helps you to understand and learn how to implement a Bayesian network using PyAgrum library.